Let's have a look at some of the tricks you can use when you're solving advanced linear equations. If you have an equation like this that has a fraction in it and you want to get rid of that fraction, you can do so by multiplying by the denominator. Multiply both sides though. You remember you have to keep it balanced. Now this only works if you have the fraction using up one whole side of the equation. If that's not the case, you need to be a little bit more careful. So what we'll do here is multiply both sides by 2x plus 3. Now that's going to automatically get rid of the 2x plus 3 on this side because the 3x has been divided by 2x plus 3. So if we then multiply by 2x plus 3, it kind of undoes all of that. So it'll give us 3x on this side all by itself. But on this side, when we do 7 lots of 2x plus 3, we will have 7 lots of 2x plus 3. And I've written it down like this with the brackets to make sure you can see that you're going to need 7 lots of the 2x and 7 lots of the 3. So put this step in each time, use the brackets, and then on the next line, you can expand out the brackets on this side, giving you 14x plus 21. Remember, you need 7 lots of both. Now to gather the x's together, there's always multiple ways that you can do this. I'm thinking I'll keep my x's positive, so I'm going to subtract 3x from both sides. Now, a lot of people will just do this in their head and say, if I take 3x off this, I'll have 0. If you like to just jot down in small writing what it is you're doing, minus 3x, just jotting it down on each side is quite a neat way of reminding yourself what to do. 14x minus 3x is 11x, and we still have our 21 on that side. Alright, rearranging it so that the x's are on one side and the numbers are on the other, we want these x's by themselves. So instead of our plus 21, we want to undo that. We'll take away 21. Now if we subtract 21 from both sides, we'll have minus 21 over here, and on this side we'll have 11x. Alright, how to get x on its own? Well, at the moment it's been multiplied by 11. So to undo that, you can divide by 11, and you can do it right there. There's no need to rewrite it, and divide this side by 11. Now 11 divided by 11 is 1, so these 11's cancel each other out, and the x is now all by itself. So on the last line, you can just write the x down on its own, potentially on this side looks neater. And this is your answer. And it's perfectly acceptable to leave it as an improper fraction like that. If you wanted to change it to a mixed numeral, you could. You'd have minus 1 and 9/11ths there. But this is perfectly okay as an answer. This example has fractions on both sides. Now you can use the same strategy here. To get rid of this 2x plus 3, you'd need to multiply both sides by 2x plus 3. That would disappear it from this side, leaving you just with a 3. But you'd get multiplied by 2x plus 3 over here, wouldn't you? Okay, and this would go. Alright, if we multiply both sides by 1 minus x, I can actually do that right on here without going any further and say, if I multiply this side by 1 minus x, potentially it would come up over here and it would cancel with this one. So it would cancel out. And on this side, I'd have 1 minus x. Okay? Now that looks a little bit messy to some people, but it's a quick, easy way of going from writing the question down to seeing the next line. Now, if you prefer to write it out neatly at that point, go ahead, but you might have actually preferred to skip that line and go straight to the next line and say, all right, I'm going to expand out the brackets on both sides. So here we have 3 minus 3x. And over this side, we need to do 2 lots of both of these. So we have 2 lots of 2x and 2 lots of 3. Now, gathering together our x's, we could add 3x to both sides to get rid of these, or we could subtract 4x's from this side. It really doesn't matter. We could also gather together the numbers by subtracting 3 from both sides or subtracting 6 from both sides. Take your pick. There's 4 next steps that you could take here. I'm going to keep my x's positive, I think, so I might add 3x to both sides. Now I jot it down here just to remind myself what I'm doing. Once you've been doing these for a while, you might like to skip that step and just say minus 3x plus 3x. They'll vanish each other, and I'll just have 3 on this side, the 3 that was here. But over on this side, 4x plus 3x is 7x, and I've still got my 6. Now we're trying to get the x's by themselves so that we can say x equals something. So let's get these 7x's on their own by getting rid of this plus 6. Now you can get rid of plus 6 by subtracting 6. So subtract 6 from both sides. That will give you just the 7x's on this side. And over here, 3 minus 6 is minus 3. Now the last step will pretty much always leave you with a certain number of x's, and it's more of them than you want. Here the x has been multiplied by 7, so to get the x by itself you just undo that, which is the opposite, divide by 7. But you have to do it to both sides to keep it balanced. Those 7's will now cancel, so the x is all on its own. And on the last line, we can write it tidily, x equals minus 3 over 7. And there's no need to put this as a decimal or anything. A fraction is far more accurate and easy. To divide minus 3 by 7, we just went divide by 7, and the answer ends up looking at you without you really having to do anything too tricky. This next example has some decimals and some fractions in it. Take your pick as to what you'd like to do first. I can spot here that 1.2 can be added to 4.8 to make 6. So I'm thinking the easiest way to tidy this up for me, first off, would be to say I'm going to add 1.2 to both sides. Okay, that's because I'm trying to remove this minus 1.2 from here. And I can do that by doing the opposite of minus 1.2 and add 1.2. But I need to do it to both sides to keep it balanced. All right, that will disappear the 1.2's here, and I'll just have minus 5y left on that left-hand side. On the right-hand side, 4.8 plus 1.2 is 6, so that's worked out nice and neat. Now I've got my 1/5 y over here. All right, the next most annoying looking thing on here is this fraction. I want to get rid of fractions, so I'm working with nice simple numbers. Now, this is the same thing as y divided by 5, isn't it? If you have 1/5 of y, it's like having y divided by 5. So if I want to get rid of a fraction, just multiply by the denominator. But there's a trick. You have to multiply every single term on the equation by that number. So if I want to multiply this by 5, I need to also multiply the 6 by 5 and the minus 5y by 5. All right, so moving across, I can probably do this in my head. Minus 5 times 5 is minus 25y. 6 times 5 is 30. Minus, now 1/5 of 5 is just 1. So I've just got y there, minus y. So that's really tidied things up a lot. I'm glad I did that here though, because at this point, if I've been multiplying these by 5, perhaps that's a little bit more tricky. And the fact that these two numbers came together to make a nice tidy number sort of made sense to do that first. It'll still work if you go the other way around. It might just take you a little bit more brain power to think it through. All right, at this point, I'm trying to get my y's together. So I've got some y's here, numbers here, and some more y's there. So I'm thinking I'll get rid of this minus y. How do you disappear minus y? You just add y, do the opposite function. But you need to do it to both sides to keep it fair. So minus 25y plus y will be minus 24y. And over on this side, we're left just with our 30. This minus y and plus y cancel each other out. Now last step, I've got more y's than I want here. So, well, we're cutting a step out. Let's divide by minus 24. Why are we doing that? Because this y has been multiplied by minus 24. So we can undo that by dividing by minus 24. Those will then cancel and we'll just have y. But to keep it fair, we have to divide this side by minus 24 as well. So y is equal to minus 30 over 24. Now I can simplify that fraction, can't I? I can divide the top by 6 and I can divide the bottom by 6. So I've got y is equal to minus 5/4 or minus 1 1/4.